Okay, number 11, solving the system by substitution. Again, none of these are solved for a letter, so we have to do that in order to substitute in to find the solution. So what I'm going to do, so I have to deal with less fractions, is I'm going to solve for x for the bottom equation. You could solve for y and substitute in a fraction, but if you have a little bit of trouble with fractions, you might want to solve for x for this one. So I'm going to add 1 on both sides, and I'll get 10y plus 1 equals x. Okay, so I'm going to substitute 10y plus 1 in for x in my first equation. So I have 7 times 10y plus 1 minus 10y equals 1. 70y plus 7 minus 10y equals 1. Combine my like terms, I'll have 60y plus 7 equals 1. Subtract 7 on both sides, I'll have 60y equals negative 6. I will divide both sides by 60, and I'll get y equals negative 1 over 10. Okay, now I'm going to take that negative 1 over 10 and substitute it in for y in the first equation. So we have y going away, and we'll have negative 10 times negative 1 over 10, which just becomes 1. So I have 7x plus 1 equals 1. Subtract 1 on both sides, we'll get 7x equals 0. Divide both sides by 7, and x equals 0. So my solution will be 0, negative 1 over 10. So I have 0 and negative 1 over 10. That's number 11. All right, number 12. Sarah took the advertising department from her company on a round trip to meet with a potential client. Including Sarah, a total of 11 people took the trip. She was able to purchase coach tickets for $140 and first class tickets for $910. She used her total budget for airfare for the trip, which was $3,850. How many first class tickets did she buy, and how many coach tickets did she buy? Okay, so we need to set up our equations. We have two different types of tickets, so X is going to be coach tickets, and Y is going to be the number of first class tickets. And we were told that Sarah took a total of 11 people on the trip, so the number of coach plus the number of first class tickets adds up to 11, so x plus y equals 11. For my second equation, it says she was able to purchase coach tickets for $140 and first class for $910. 140 times the number of coach tickets will be 140x, and then 910 times y for number of first class. So you add that together, you have 140x plus 910y equals my total amount paid, which was $3,850. So now I'm going to use substitution to solve the system. So I'm going to go ahead and solve the first equation for y. So I'm going to subtract both sides by x, and I'll get y equals negative x plus 11. So then I'm going to substitute that in for y for the second equation. So I'm going to take the y out and replace it with negative x plus 11. I distribute 910 inside, and I'll get 140x minus 110x plus 10,010 equals 3,850. Combine my like terms, I'll get negative 770x plus 10,010 equals 3,850. Subtract 10,010 from both sides, I will have negative 770x equals negative 6,160. Divide both sides by negative 770, I will get x equals 8. Now I need to find y. I'll substitute that in for my equation for y, and I'll get y equals negative 8 plus 11. So negative 8 plus 11 is 3. Now remember that x is the number of coach tickets bought, and y is the number of first class. So my first answer wants the number of first class, so that would be y being 3. So I will have 3 for first class, and I will have 8 for coach. And that would be my answer for number 12. Right, so number 13, recall that two angles are complementary if the sum of their measures is 90 degrees. Find the measures of two complementary angles if one angle is 17 times the other angle. So what we need to do first is establish our variables. We know complementary angles add up to 90. We're told that one angle is 17 times the other, so make the first one automatically x. the other one will be 17 times that, which is 17x. The sum of them is 90, so our equation will be x plus 17x equals 90. Add them up, you'll get 18x equals 90. Divide both sides by 18, you'll get x is 5. Now x, remember, is the smallest angle, so our first angle, our smallest one, is 5 degrees. The larger angle would be 17 times 5, which would be 85 degrees. So putting that in, our smaller angle is 5, and our larger angle is going to be 85. And that's going to be our answer for number 13. Number 14, it wants you to tell whether the system has one solution, infinitely many solutions, or no solution. Okay, so let's take a look at it, because we're going to have to use elimination. So I'm going to rewrite these equations so that x's and y's are in the same spot, corresponding with each other, equaling our constant. So I just rewrote them. No adding or subtracting or anything. So then what I'm going to want to do is multiply all the top equation by -1, because I noticed that both the x's and the y's are the same number, but the same sign, and I want to make them opposite so I can eliminate them. So multiplying everything on top by -1, I'll just get -9x minus 5y equals -18. So now I can add that to the positive 9x plus 5y equals 13, which is the second equation. So -9x plus 9x is 0. -5y plus 5y is 0. So I have 0 equaling -18 plus 13, which is -5. 0 does not equal -5, so we're going to say that the system has no solution. So our answer for number 14 is no solution. Number 15, the rectangle shown has a perimeter of 92 and a given area. Its length is 6 more than 3 times its width. Write and solve a system of equations to find the dimensions of the rectangle. So let's go ahead and try to set up our equations. So we know the formula for perimeter is going to be 2 times the length plus 2 times the width, because in the rectangle, both lengths are the same and the widths are the same, and you add up all the sides to get that. So we have 2L plus 2W. We're told our perimeter is 92, so that equals 92. Second equation, the length is 6 more than 3 times the width. So we know length represents L. In math, is means equals. And then we have 6 more than 3 times its width. So 3 times is 3W, plus 6 will be 6 more than that. So now I'm going to substitute what L equals in for L in the first equation. So take the L out, replace it with 3W plus 6. Now I'm going to distribute the 2. I'll get 6W plus 12 plus 2W equals 92. Combine like terms, I'll have 8W plus 12 equals 92. I will then subtract 12 from both sides. I'll get 8W equals 80. Divide both sides by 8, and W equals 10. So now my length, or now I need to find my length, put that 10 in for W, so 3 times 10 is 30. 30 plus 6 is 36. So the length is 36, and the width is 10. So I have my length is going to be 36, and my width is going to be 10. And if I multiply those together, it will also give me my area. So that is my answer for number 15. Okay, number 16, we are solving the system using elimination. So what we need to do first is see if either both our x's or y's are the same number but different signs. Looking at both of them, the y's are the same number but different signs, so we can add them up to eliminate it. So we have 4x plus 2x, which is 6x, 6y plus -6y is 0, and 12 plus 6 is 18. So we have 6x equals 18. Divide both sides by 6, and we'll have x equals 3. Now we need to substitute it back into the first one to find y. So x is 3, so take the x out, replace it with 3. 4 times 3 is 12. Subtract 12 on both sides, you'll get 6y equals 0. Divide both sides by 6, and y equals 0. So my coordinate's going to be 3, 0. So in parentheses, I'm going to put 3, 0, and that is number 16. Number 17, I am also solving this system using elimination. So looking at my two equations, I notice that I have a 6x and an x, so they're different numbers. I have the same number for y's, and the signs are the same. I need those to be different signs so I can eliminate it. So what I'm going to do is multiply the top equation by -1. I very easily could have done it to the bottom equation and got the same answer. Okay, so multiplying the top equation by -1, I'll get -6x plus 7y equals -4. Now I add these up. -6x plus x gives me -5x. The y's become 0. -4 plus -11 gives me -15. So I have -5x equals -15. Divide both sides by -5. I'll get x equals 3. Now I'm going to substitute that in for x. So 6 times 3 is 18 minus 7y equals 4. I now subtract 18 from both sides. I'll have -7y equals -14. Divide both sides by -7 and y equals 2. So my ordered pair would be 3, 2. So put that in parentheses 3, 2, and I'll get that for 17. Number 18. A bicycle store costs $3,900 per month to operate. The store pays an average of $40 per bike. The average selling price of each bike is $100. How many bicycles must the store sell each month to break even? Okay, so we need to set up our variables first. We see that we are selling bikes, either buying them or selling them, so we're going to have X represent the number of bikes sold. Also, Y is going to equal both our expenses and our income, depending on our equation, because we have expenses being discussed and we have our income being discussed. Okay, so that's X and Y. Now, for our expenses, the store costs $3,900 to operate, and the store pays an average of $40 per bike, so that's the expenses. So Y is going to equal 3,900 plus 40x, because per bike means to multiply and the number of bikes is x. My second equation is going to be my income, and we're selling each bike for $100, so y would equal 100x. Now we're asked to find how many bikes must be sold each month to break even. So to break even means they're equal, so we set them equal to each other. So now we subtract 40x from both sides. We'll get 3,900 equals 60x. Divide both sides by 60, and x will equal 65. So that is the number of bicycles sold, 65. And that's number 18.